It should be streaming and such. So it should be a draftphysics.com, debatephysics.com also. Video presentation. Should be anyway. And so I'm just going to play a one of the AI videos that Notebook LM or whatever it's called produced. That wasn't really, I wouldn't call it a complete clunker, but it just wasn't good enough. So the one I really did like was Fake AI number 2. I called it something like that. So somebody got like 100 views on the website. So I would appreciate if people are interested. It's a pretty good half hour of going over most all of the subjects fairly well, frankly. Without having to do too much correcting. Anyway, so we'll play some of this and just use it for fodder for making the argument more, let's see, ironically, to make it in a more human way, more inviting, more, because the AI is so nice and it's so pleasant, where the regular human can be irritating and obnoxious to the senses. But anyway, we'll see how that goes. I won't be... Let's see if I can tell what the volume's doing. We'll see.
What if I told you one of the first formulas you probably ever learned in physics, a cornerstone of how we understand the entire universe, might be just plain wrong? Today, we're digging into a source that makes a pretty wild claim. The kinetic energy formula is a 300-year-old mistake. Okay, so let's get right into it. At the very heart of this whole argument are two different ways to define the energy of something that's moving. On one side, you've got momentum.
Right. Sorry, just try to fix the volume. I still haven't got it right. I think it's a little too loud, right? That's my guess. Louder than I am. It's always something. These computers, probably there would be adequate. We'll see how that goes. All right. Too much, then you get an echo. Too little, you get it's always something. So yes, it's kinetic energy versus momentum, and obviously these illustrations don't help any because kinetic energy isn't, it's this scalar energy. So there's no point in showing it as vectors going in a direction because it doesn't do vectors in a direction. It's some sort of magical energy that doesn't go in a direction. And so, yes, it's impossible to draw. Yeah, so even AI couldn't draw it because it's impossible to draw because it's nonsense. It doesn't make any sense. Yeah, exactly. I mean, look, the whole thing is some guy just showed up and said, I think this MV squared stuff looks really cool. I think it mathematically looks cool. And I have no experiments to defend it. I'm just going to tell you, okay, that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet because the same number of feet distance happens per mass. And that's all that matters, is how many pounds went how many feet. Because somehow gravity, even though Galileo already proved it was a time-dependent force, that is, it came in units of time, we're just going to forget all that. Yes, so what? I mean, it's that silly. And again, you can compare it to so many different ways. All forces, essentially, that are constant, like spray paint or wind or water in a stream, all of those forces do what gravity does, which is they're time dependent. The faster you go across the stream, the less the stream moves you. The faster you go through the paint, the less paint gets on you. I mean, it works exactly like gravity. And it's just ironic that, I say this to smart people. There's people in this audience that aren't stupid. And instead of reacting by saying, yes, that's interesting, we ought to really, do some experiments and prove this one way or the other, right? Let's really do the experiment and see what happens. No, they don't say that. They just say, shut up. We don't want to know the truth. That's what they say.
Which is pretty simple. Mass times velocity. But on the other, you have kinetic energy. 1/2 mass times velocity squared.
Now, for Leibniz, it was just mv squared, okay? So there was no half, so it wasn't even moderated. So the the amounts of energy were gigantic, and but it's still that's the case with the gun. For example, the bullet versus the gun recoil, it's 500 to 500,000. I mean, the gigantic 1,000 to 1 difference, 2,000 to 1 difference in the claimed energy of an object. These are insane statements about reality, frankly.
The source we're exploring argues that these two are totally incompatible. They can't both be the right way to describe the fundamental energy of motion. And
both formulas won't land you on the moon. Both formulas won't even get you out of the atmosphere. And the fact is you can sort of prove that momentum's the only one that's going to do you any value. It's the only one that's going to move a spaceship is momentum. So I should just be able to get have the conversation end right there, right? If you're just saying that, okay, you can't even move a spaceship in empty space with this kinetic energy, the wooey scalar energy doesn't show up and do any work. So isn't it time just to let it go? I mean, why are we bothering having an argument about it? I mean, if it can't move a dead piece of matter in space, then this kinetic energy must not be energy.
And this isn't some new debate. It actually goes way...
So that's the problem with this image. It's really crappy. Let's see if I can get rid of that. Can't get rid of the... How do I get the... the crap.
Way back to...
Yeah, see it disappears. No, it still didn't disappear. That is funny. I can't get rid of the stupid bar at the bottom. Yeah, how do I get rid of it? Funny. It should go away. I know I'm distracted by little bullshit that doesn't matter, but it's annoying. It shouldn't be there. Let's see what's the space.
The 17.
Yeah, it still won't go. All right, so we just have to live with it. But anyway, it's obviously a pretty crappy image of Newton and Leibniz. This is not Leibniz, and this isn't Newton. So both images kind of suck. But whatever. It does so well in other circumstances. Just kind of funny how the AI gets it 1 minute and doesn't get anything the next minute. All right, continuing.
Hundreds. It was a showdown between followers of Isaac Newton, who were all about momentum, and Gottfried Leibniz, whose idea of a living force...
So it wasn't just Newton. It was Galileo and Descartes, so the three big ones of the era, defining, making most of the durable, reliable statements about our circumstances in terms of the physical reality, the most insightful gentlemen of their time. They all clearly were momentumists. They were not Leibnizians. Yeah, no.
Later became what we call kinetic energy. The claim is that physics took a huge wrong turn way back then, and we've been dealing with the fallout ever since. So, how do you even begin to challenge such a fundamental idea? Well,
so apparently you can't. And even though the fundamental idea isn't well demonstrated by any physical evidence. So again, if I ask to see an experiment that demonstrates 25 times the fuel to go 5 times as fast, or that demonstrates something going 5 times as fast doing 25 times the work, they will show me nothing. Because nothing approaches confirming that fact. That's supposed to be a fact according to their theory. And it isn't made evident ever. And so that should say to them, okay, why am I selling something I can't show the proof? And so they always show you these contrived experiments, and one of the famous ones is they have a name for it, when they drop a weight over a pulley. They call that something. Some sort of fame, but it's such a nonsense because they're basing it again on their wrong assumption that gravity is about how far you fall and not about how fast you fall. The time, how long it takes you to move a distance in gravity will decide how much gravity affects you. If something supports me and I'm in gravity, it means the gravitational pressure is going into that object that's supporting me, and it's collecting more and more energy. So if something holds me in the air for 10 minutes, it's going to have 10 minutes of gravitational force that it had to overcome with a counter force. it's in units of time. It didn't do no work. It did a ton of work. Because even though it didn't move any distance, it pushed against gravity. And it's just so obvious. So why do we think that every time something is dropped with a cord tied to it to change how fast it falls, that every time it falls it's exactly the same amount of energy, when obviously if I drop this really slowly, I'm going to do more work than if I just let it go, let it drop. If I do this, I don't do hardly any work at all because I'm yielding to the force. But if I hold it against the force, I'm going to be doing a lot of work. And, again, I have to explain this to, intelligent people, that if this falls at a different rate, it means there's a different amount of force that's collected. So, I have, I guess we'll illustrate it. What the hell? I'm going to get this thing to select. I don't know why this thing's not selecting very well. So I have pointed it out before, but I'll point it out again. So if I put something on a slope, okay, you could understand that, and rolled something, that it's going to roll very slow depending on how high that slope is. So if the slope was a very great slope, okay, very high pitch slope, well, right, you can understand the thing that's going to roll down that slope is going to roll much quicker. It's going to get down that slope much quicker. It's dropping a lot more distance, okay, and it's going to be moving a lot faster. And but the trick is what's the other thing doing on the surface? The other thing is rolling slowly, and the whole time it's rolling, okay, even though it's going to drop just at 1 inch. All right, this is just 1 unit of distance. Say this was 10 units of distance. This is just 1 unit of distance. Right? Okay. You can sort of understand this is going to roll very slowly. All right, and the whole time it's rolling, the mass will be putting pressure into the ground. It's full pressure. And the faster this rolls, you can understand that the faster it rolls means it's over the surface less amounts of time. And so it's actually putting less pressure. There's less friction into the surface here. It's losing less energy to the surface. And this is obviously losing a lot more. So how could it end up falling the same speed it would fall if it just fell? If it just fell this 1 inch, all right, it's going to leave going this way, okay? It's going to leave going this way, all right, with the same velocity that it would have hit the ground here if it just fell straight. But what did it also do? Well, it also did all of this. So it created all of this heat. And where is all of that equal? Well, that equals the extra time. So it proves that it's a time-dependent force, because the fact is, because it takes so much longer to fall that one little bit of distance, that whole time it was creating all this extra energy into the surface. Undeniable. So the falling height, the falling, if you stop something from free falling, it's not going to do so and create the same amount of energy. So if it's going some other velocity besides its free fall speed, because you've suspended it in some way and tied it to a car, well, then the extra energy is going to end up in that car. Yeah, it's just so obvious. And so they do this to calculate kinetic energy, because they're pretending only 10 units of energy went in, when no, because of this extra time, you put in 30 or 50 units of energy. Anyway, just not very bright that people fall for that. They can't figure out, I have to explain it. That if something's not falling the same speed, it can't have the same energy. The longer it's in gravity, the more gravity it collected. Just a fact.
The source starts by laying out some really simple scenarios where the kinetic energy formula seems to create impossible situations, paradoxes that suggest there's a serious lack of actual experimental support for it.
So these are pretty lame images. So in some of these videos, it does really quite brilliant drawings, and in in this one, not so much.
The first challenge is a thought experiment. It's a question that seems almost childishly simple, but according to the source, modern physics really struggles to give a straight answer without contradicting itself.
All right, picture this.
Okay, so this, so picture this, a ludicrous drawing. So obviously for this to mean anything, you'd have to understand that, well, let's imagine these two exhaust ports were suspended above the center of gravity. So that way, there's no way it, they wouldn't be going through the center of mass. So let's just understand that there's a big weight here at the bottom or something. So you get the idea that it would turn if one side pushed more than the other. But I mean, it's obviously not a normal rocket that shoots both ways. So, it didn't quite get the concept that we were talking about a rocket pointed this way, and we were talking about thrusters being used to turn the rocket. And it just didn't quite get that right.
A spaceship is just floating in the total emptiness of space. It's got two engines pointing in opposite directions. Engine A on the left spits out a tiny little 1 unit mass, but it does it at an insane 1,000 miles per hour. At the exact same time, engine B on the right pushes out a huge 1,000 unit mass, but super slowly, at just 1 mile per hour. So the question is, does the spaceship turn? Now this is where it gets really weird.
So, so again, we switched from a pretty good image in terms of an image into this, I don't know what this is, mess. Frankly, but it does just illustrates the fact that the momentums, it all makes sense. So momentum wasn't broken. Momentum wasn't broken back when Leibniz decided to break physics. Momentum worked. It worked for Descartes, it worked for Galileo, it even worked for Newton. I mean, they did have some doubts about some experiments maybe making free energy, but everybody knew there was no perpetual motion, and they knew that wasn't going to happen, and they were pretty certain of it, let's just say. But they had to have an open mind because, they didn't have what we have in terms of the science. So they couldn't be sure of those facts. But look at the preposterous mess the theory makes. I mean, it obviously doesn't make any sense that one side, the gun, has 500,000 units of energy coming out one side and only 500 units of energy going the other way. How could the explosion make that happen? And it just can't. It doesn't make any sense, and it's just silly, and it's stupid, and people shouldn't have fallen for it. It's really depressing that they did, and it's really even more depressing that technically savvy people now still fall for it. How can they? It doesn't take much thought to look at those numbers and say it just can't work that way. How can I do that? And theoretically, I could do that on a lever. Theoretically, I could have that kind of preposterous differential if I could make an ideal lever. I could have some kind of preposterous differential like that. Now, I can make a lever that has the 4-to-1, relationship, and I showed that. Where you have a 1 mass, 4 distances moving 4 times the velocity, and you have a 4 mass at 1 distance moving 1 velocity. And it makes perfectly rational sense. The lever's balanced. It will balance. It works perfectly. It makes sense that it's oscillating with the same energy when it goes up this way, same energy as when it goes down this way. It's an oscillator. It's working. It's functional. Makes no sense at all if I pay any attention to kinetic energy theory, because I have 4 times the energy on one side. How can I have 4 times the energy and have an oscillator that works? It's not possible. I shouldn't have to argue this with reasonable people. They should concede that's a problem. And they got to come up with a pretty good explanation, because that's a problem.
Take a look at the math. If you calculate the momentum for both engines, they are identical, 1,000 units each. So Newton's laws would say the forces are balanced, right? The ship shouldn't turn. But if you calculate the kinetic energy, engine A spits out 500,000 units, while engine B only puts out 500. That is 1,000 times more energy. So if kinetic energy is the real measure of force, that ship should be spinning like a top. It's a total contradiction.
And this really gets to the core of the problem. Now,
Yes, exactly. So you can't have it both ways. Both these can't be real. Either momentum is energy or kinetic energy is. And that's, what I've been arguing for the last, 7 or 8 years here. And I haven't been gotten any reasonable counter arguments pointing out how we have decisive evidence proving, because we don't. Like I said, I can point to like the Mythbusters. They have car crash evidence. They have crushing clay evidence. There are some experiments that produce pretty good evidence. I can point to the experiment right up there. And I can point to the one where they did the 4-to-1 mass, and it's even more dramatically obvious that the lighter cart is going 4 times faster. That the momentum is conserved and the kinetic energy is not.
Mainstream physics has ways of explaining this, talking about energy being a scalar and momentum being a vector.
Yeah, they can talk about it, and it doesn't still. I don't even know how this even makes any sense to anybody. How can anybody make sense out of this word of scalar energy? That somehow energy doesn't have to be in the form of a photon moving in a direction. Or energy doesn't have to be in the form of a pen moving in a direction, or it doesn't have to be in the form of a baseball or a wrecking ball, or something moving in a direction. Where the fuck do they get this notion that there's some kind of energy that doesn't have a direction in its expression? Now, obviously you can store energy. I can store energy in a balloon, and I can release it in any direction I want to. Okay? So we know that it's directional. And we know that I can change the direction for free. So what? Doesn't mean there's something called a scalar in there.
But the source says that's just avoiding the fundamental issue. As they put it, you just can't have it both ways. One of these things has to be the true measure of force, and the other has to be, well, just a number in an equation.
No, it's a fable, and it's a nonsense. And it was invented by an insanely religious kook who really wanted this God stuff to match the physical world and all that kind of stuff. He had a definite unpleasant, suspicious bias, let's call it. And so there isn't a really good reason to trust his physics, trust him as a scientist.
And this isn't just about futuristic spaceships. The argument brings it right back down to Earth, to one of the oldest and simplest machines we've ever created. Turns out, the humble lever shows us the exact same paradox. Okay, look at this perfectly balanced lever.
Okay, so obviously not drawn very well. It's got the masses moving all over the place. The 4 unit of mass is small and the 1 unit of mass is big. Okay, so that's why I didn't play this video too much. Just because that's such a obviously silly mistake to make. And obviously all these arrows going in regular directions that don't have anything to do with the experiment. So obviously not a very good diagram of a lever, okay, where you're balancing the 1 mass at 4 units of distance versus the 4 mass at 1 unit of distance from the fulcrum. But that's what he's verbally describing.
On one side, you have a little 1 unit mass moving with 4 units of speed. On the other side, a big 4 unit mass is moving with just 1 unit of speed. And just like the spaceship, the momentums are perfectly equal at 4 units each. That's why the lever balances. But check out the kinetic energy. Side A has 8 units, and side B has only 2. So here's the kicker. If kinetic energy is a real, physical thing, then this simple machine has 4 times more energy on one side than the other.
And the key point is the lever is balanced in all positions if you have a fulcrum in the center. And the real trick is this, so it's showing you that it doesn't have anything to do with height or any of that crap, because the gravitational potential is the same in all of these locations. It's 9.8 here, 9.8, 9.8. So you really don't get there's not enough of a difference for it to rebalance the weights if you have the fulcrum in the center. So they are equal. So it's all about the motion. It takes the same work to move the 4 mass 1v as it takes to move the 1 mass 4v, and that's what's proven. And the only thing that happens when you suspend the lever, what you're really doing is taking a little bit of the length of the lever and shifting it from one side to the other side. And so that's all happens in the experiment. When I oscillate the lever, what's really happening is the mass of the lever just shifts over to this side, then it shifts back over to this side, and it shifts over here. So it's exactly the same mass that's actually moving the lever. So the same mass following the same speed moves the lever, and it clearly can move the one mass up against gravity, okay, as easily as it moves the 4 mass up against gravity at 1v. Proving the momentums are the same and the momentums are the work.
That means it's literally creating energy out of nothing, which completely violates the law of conservation. The source argues that any real-world experiment you could possibly run will always show the lever balancing based on momentum, not this weirdly imbalanced kinetic energy. All right, so if kinetic energy is the problem, what?
So again, not a very creative, some of this artwork is just so, it's so nothing. Some frames are just so blah, and then and then others are so elaborate and interesting. It's just funny how there's such a huge inconsistency in what it generates as artwork.
It's the solution. Well, the source proposes that we have to kind of rebuild physics from scratch, starting with one single fundamental particle. This new model is called the push universe.
So it's not one fundamental particle. Obviously, I'm arguing that there's force, Sisyphus, and there's boulders, electrons and protons. And because there's electrons and protons, there's proton Sisyphuses and electron Sisyphuses. They don't push each other's boulders. So, and then you just have this simple argument that whenever an electron Sisyphus touches a proton boulder, it turns into an electron Sisyphus, and vice versa. So it's, but it's not very complicated. But all of that, all you need is something, a mechanism that simple, and it duplicates charges. So it completely creates exactly what you would see in a Maxwellian diagram. So a Maxwellian diagramming of what would happen if, it will exactly duplicate what would happen if. And it's that simple. So simple mechanical systems can create the phenomenon, can explain the function. You don't need woo.
And its most basic piece is something called a force bit.
Like you don't need, they have a strong force and it's invented out of nothing. You don't need it because the simple argument is if I want to get two North Pole magnets very close to each other, all I do is stick a South Pole magnet in between them and they'll move right in next to each other. Not a problem. Fact.
The best way to think about it is that it's not a particle carrying momentum, it is a tiny packet of momentum.
So it doesn't matter whether it's a particle carrying momentum or it is momentum. The point is it's the same thing. Everything that moves is carrying momentum. So whether it's in the form of force, Sisyphus, or whether it's in the form of boulder moving, if it's boulder moving, it has Sisyphus. If it's a Sisyphus, it has Sisyphus. So you can get the idea that there's nothing but this idea of motion. And yes, the argument is the force has all the motion, and the matter only moves after it has collected force from the environment.
A little bit of push that's always zipping around at the speed of light. And the rules for how these force bits work are super simple. There are only 2 of them. Rule 1 is absorption.
So there are 3 of them. So again, I don't know why I got these things wrong. This is after it's, it had a few lessons already. so this is the more source material I gave it. I gave it more source material and it got dumber. So just kind of shows that the AI is kind of, there has these subtle defects in its thought process. Obviously, it shouldn't get dumber as it gets smarter, but it does.
A force bit hits a piece of matter and gives it a push. Rule 2 is reflection. It just bounces off. That's it.
So those are terrible describers of sticking and bouncing off. So you couldn't really tell looking at these 2 weird diagrams that that's what that was illustrating, is reflection and absorption. And it doesn't look much like either one of those things.
The claim is that every single interaction in the entire universe is just some combination of those two simple things happening over and over again.
So in this kind,
And but this one sort of has the two colors happening now, but it doesn't going to talk about them. So, but yes, they're all the same thing. So all the forces all move the speed of light. So it should be called the speed of force. I mean, the fact that nobody will even engage in a conversation about that simple truth, that if we were to be reasonable about the science maturing into something reasonable and rational, that there would be a real conversation among physicists that maybe it's time to call it the speed of force, not the speed of light, because all the forces are connected to the speed of light. They're all, that's their core function, is a clear reference to that speed. They can go slower, they can demonstrate something slower, but there's a real obviousness that their fundamental feature is they move that speed, especially for gravity. Now, electricity gets complicated because it depends on how good your conductors are and lots of things, whether you can achieve those kind of speeds. But the fact is that happens to light too. If you put light through a medium, it doesn't move the same speed, so it's not really the speed of light anymore. Right? So, we shouldn't play games, but all the forces have that same maximum speed, and that should be acknowledged, and so it should really be called the speed of force. Should be. I say so. Why is this so small? Can I make the chat bigger? I imagine I can. Yeah, that worked. Okay. So let's see. Somebody said momentum equals force equals energy, gravity, mass, pressure. Acceleration is not the same thing, so I wouldn't put that in the same category. Acceleration is a change in velocity. It's not really a force. But work, yes. Distance, no, not the same. Inertia is just mass, so mass isn't energy, so I don't agree with you there. Light is a phenomenon, so it's, again, it's, no. Space, derp. Well, whatever. So fuck you and your derp. Everything is one thing. No, not everything is one thing. So fuck you again. Speed equals light. I don't know what that even means, so fuck you again. So I think I'll just delete this shit and say, try again, or I'll just block you. How about that? No. Do you want to try to say something reasonable and fair to the conversation? So you don't think it's the speed of force. Could you just give me some reason why all the forces shouldn't be called it's the speed of force, because somehow magnetism doesn't go the speed of light and that gravity doesn't go the speed of light? Is that your assertion, that those forces don't have that speed limit? They don't have that speed, frankly. Magnetism always goes the speed of light. Are you going to argue for something else? Fuckhead? Shit for brain? Turd head? Garbage mouth? I mean, this is just such petty, useless turd shit. You can't do any better than this as a fucking argument? God damn. Just so pathetic. Tip, tap, right angle. Fuck you. I shouldn't have bothered giving you a chance, right? You can't do anything rational. Fuck off. God damn it. I hate humans. What actual pus? I mean, they're just fucking balls of fucking pus. Someday, I just hope they come to get you, fucker. The antibiotics show up at your goddamn house and give you what you deserve. Shit.
in a universe, matter is totally passive. It doesn't have an engine.
Right. Electrons and protons are not doers. They just aren't. They have it done to them. Okay? They sit there, they're the boulders. And all it is, boulder, 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 boulder. And then there's these Sisyphuses or fish or whatever you want to think of them as, flying through the universe at the speed of light. They bang into these boulders, and if it just happens that more of them bang in from one side than bang in from the other side, then it's going to go that way. And now it's a carrier of force, and now it can impose a momentum on something. And that's it. But that's all there is. Heat is the same thing as electricity, or it's the same thing as the little shot coming out of a shotgun in a way. It's just energy, except it's in all kinds of little directions. And it's little tiny bits of energy moving in little tiny directions, hitting lots of stuff as it's going. And so it's the same motion in a different environment, a smaller environment, a more crowded environment. So heat doesn't move as fast because, it's moving through a whole bunch of stuff, a thick medium. So obviously it moves slower, like you in water. Like even a shotgun in water, right? If I shot a shotgun in water, you might even be able to visually watch the shot stop and all, collapse. Lose its energy, just like heat dissipates the energy into smaller and smaller little bits of energy. Just so damn obvious.
It just sits there until it gets pushed. All the forces we know, gravity, light, you name it, they aren't some mysterious fields. They're just the physical movement of these force bits. In energy is simply a count of how many of these bits there are, either flying...
Right, so that's all there is. There's just Sisyphus power. They're the only things that have any power. And they could, in substance be just all freely flying and all the matter could be stationary, or they can be pushing matter. So the more densely consolidated they get, like for example, when they're pushing into the earth, creating gravity. All right, I could draw that pretty simply. I mean, it's a very clear, I think, explanation that uncomplicates the subject pretty dramatically, in terms of understanding which one I have to move here. This is where the moon hit the earth. I don't know what that was. Anyway, so you have the force coming into the earth, and the idea is it gets slowed down because this force that's moving through the universe, these Sisyphuses, the little matter bits, so all these different kinds of photons, graviton, magneton, photon, all kinds of radio waves, microwaves, all kinds of different forms of these little bits that we can see and the ones we can't see. I would argue we can't see any that's proton force. So the only force we can see is electron force. We can only see the stuff that moves electrons. We don't see any radiation that moves protons. And so that half the energy in the universe, we can't possibly even see it. All right. But we don't have any instruments that can see it. And so, what happens is it's creating a bunch of heat inside the earth because it's moving a bunch of matter inside the earth. And, it can be understood that it keeps hitting all of this stuff, and all of this stuff keeps moving in towards the center. We know the pressure gets bigger and bigger, so the density of the force is getting more and more compact. So what you're doing basically is you're saying if the force had a separation like this, okay, out in the free universe, inside the matter the force looks like this, okay? There's a lot more Sisyphuses per inch, per square, per cubic inch. So you're condensing the amount of Sisyphuses that are stuck inside the earth. So you're condensing, and what does that condensation mean? Well, it means that there's more stuff trapped in here than would be trapped in there if it was free, and so that's why there's a force differential. So the force coming back out is less than the force that went in because it's being condensed, okay, constantly condensed, and then a second later it's re-expanded, but it's always for this exact moment. The force that should be pushing back at me, equalizing my condition, it can't get to me because it's pushing matter right now. So I'm going to fall into that differential until I hit the matter. And then I won't fall anymore. and then I'll add my pressure that I'm not adding when I'm floating. Yeah, because there's no differential when I'm actually getting what isn't being blocked or consumed by the planet. So you can just understand it's just about density of these Sisyphuses. They're less dense in the free space than they are inside the galaxy or inside the solar system or inside of a meteorite. Yeah, that's probably... The smart people will understand.
Free or in the middle of pushing something.
Okay, I know what you're probably thinking. How can a model that's so simple possibly explain something as massive and complex as gravity? Well, this model says gravity isn't a pull at all, it's a push. And
So again, the idea of a pull is so, not so much, right? So that's another argument. Should I really have to push that and push that and push that? I mean, all of you people just can't concede that, yeah, if we're really going to talk about how something elemental would work, elemental push is really easy. You just throw something there, and I pushed. But elemental pull, there's no simple elemental pull. Because I have to create some sort of vacuum or something. I'd have to pull stuff, push it this way, like behind me, and then that would somehow create a vacuum or something. I mean, it's just a pull isn't going to work. It's not elemental. The push, the hit, is so simple. And so again, you won't even have that conversation and get real and say, okay, come on, what's the likelihood that gravity is some sort of magical pull mechanism? When it's so much more sensible to think that something the Earth is doing, all right, is creating a differential in what's coming from the outside and what's coming from underneath. And that's all you really have to say, right? I mean, isn't that all you have to show? And as soon as I tell you, well, the Earth is, 5,000 degrees centigrade in the center, what do you think where do you think that comes from? Maybe that 5,000 degrees has something to do with the fact that you're stuck in a differential, because the energy that was supposed to keep you floating is melting the center of the Earth. Duh. You really can't understand that argument. So, I'm sitting here and I'm just saying, as a fair cop kind of person, you really think that's implausible? I mean, impossible even. You think so? It's just not possible that something like that could explain the circumstance, so that you really shouldn't be saying stuff is pulled into the Earth until you really prove it. It really is. This demonstrates again that there's just, the human character is just so low. We've reached a point in human history where human character has disappeared, and humans have reverted into just crude and rude monkeys. You just don't have any dignity as thinking devices anymore, because you can't do any of it honestly. You're all just bigots, for fuck's sake.
imagine the entire universe is filled with a constant storm of these force bits pushing in from every direction. But a huge object like the Earth gets in the way. As the bits pass through it, some of them get absorbed or slowed down, creating a kind of pressure shadow in this universal storm.
The source explains it in a really intuitive way.
All right, so he did a really bad job because, again, I'm not saying they got absorbed is a tricky word to use, and I mean, clearly what I'm saying is delay is the key word. Yes, they're getting slowed down. The force can't go the speed of light anymore when it's pushing matter. So obviously if a force bit had to meet an appointment somewhere, it had to go to the dentist at 4 o'clock. Can't get there.
Basically, there's more force pushing down on your head from space than there is pushing up on your feet from the Earth, because the Earth is blocked.
And obviously it doesn't push on your head and it doesn't push on your feet, and that's why gravity is unlike any other force in the sense that it is actually moving your electrons and protons. And so you can never feel gravity affecting you because it's going to move every single bit of you. Every atom will move exactly the same speed. So you'll never be able to detect you're being pushed by gravity because you won't be able to feel the difference. nothing will move at any different speed. Where if the floor pushes on your material matter, it pushes on your feet first, and then you have to wait for all the other material goop to be readjusted. The water levels and all that stuff take a lot of time. The skeleton goes much quicker. I mean, it's all kinds of differences in how the motion is transmitted through your body. But gravity, it's transmitted based on the nuclear bits. So you feel nothing. You can't feel gravity pushing you. You can only feel the earth hitting your back.
Blocking some of those force bits coming from below. And that imbalance of pressure, that's what we feel as gravity. So, if this argument is so simple, using levers and basic logic, why isn't it being debated everywhere?
Why isn't it at least acknowledged as a reasonable thing to talk about? The speed of force, push-averse, recognizing that none of this was broken, okay, that, there wasn't something fundamentally broken about the theory of momentum. For 2,000 years, everybody thought levers were doing a good job of conserving momentum. None of this theory needed to be understood to well understand the world, to predict accurately, to build a boat that floated.
Well, the material we're looking at points to a very specific showdown on one of the biggest websites in the world as a possible...
All right, so this is kind of aggrandizement here. Yes, there was an argument on a Wikipedia page because Wikipedia isn't about the truth. It's about the propaganda preached by the Catholic Church.
Reason why.
The author of this theory went to the discussion page for the Wikipedia article on thrust and tried to raise these points, specifically that spaceship paradox, arguing that the official article was...
So this is kind of a good drawing, right? You have the two spaceships on either side of a lever. You could sort of understand the argument from that point of view. That if the spaceship shoots big blobs at slow speeds versus little blobs at high speed, that somehow it's not going to be equal, even though the same force can produce both those effects. The same force can produce the yellow cart going fast and the blue cart going slow. Same force can produce those two thrusts. Now, the kinetic energy theory says the yellow thing has twice the energy, but it doesn't. It won't do twice the work, and it didn't take twice the energy to make it go twice as fast. It did not take twice the energy. Just a fact. It didn't.
Basically unscientific. The response he got from a Wikipedia editor was pretty quick and to the point. The editor said that Wikipedia has to be based on established, reliable sources, not on original ideas or thought experiments.
So it didn't really... there was worse than that. I mean, it was just basically saying we're not here to test any of it, or to prove any of it, or to demonstrate any of it, or to argue any of it. We're just going to tell you what the truth is because our authorities say so. Not because experiments say so, just because an authority says so, whatever an authority by their definition is. So if it's a college graduate, he can tell everybody else what they must believe, but he doesn't have to defend what he believes. And that's the part that's just such bullshit. Of course he should be required to defend it. If you're going to preach it, you should have to defend it. If you're going to say it takes 25 times the fucking fuel to go 5 times as fast, you should be able to show it happening in this universe somewhere. And it happens nowhere.
And just like that, the conversation was shut down. The editor's final comment basically branded the whole argument as a fringe theory, and that was the end of the discussion on that platform.
The author's reply was pretty fiery. He accused the platform of basically protecting scientific dogma. And this whole exchange really shines a light on how incredibly difficult it can be to challenge scientific consensus, especially in forums that are designed to rely...
Right, it just shows how humans are scum. I mean, this isn't that challenging, right? I mean, what is the big challenge? To argue for push and to make the simple argument that pull isn't a very viable elemental function, just like a wave isn't a very viable elemental function. You can't really just sit there and say something elementally waves. You know, it does require a medium, or it requires some kind of thing that's forcing the wave thing to happen. It requires something. So, yeah, these aren't really... This isn't flat Earth arguments. These are perfectly reasonable arguments that deserve a fair response. Not just knee-jerk, antagonistic, insulting tripe. And as the previous chatter proved, that's all they have, this essential X. Stupid fucking bastard. Anyway.
Only on what's already been published.
All of which brings us right back to where we started, asking questions about a piece of physics that most of us just took for granted.
Look, the source we've walked through today argues that from simple levers to spaceships, the actual observable...
levers, ballistic pendulums, spaceships, pulleys, gears, hydraulic systems. In every single case, all of them demonstrate this 1/2 mv squared thing doesn't work.
Evidence seems to back up momentum every time. It leaves us with a really critical question. When a core theory seems to create these paradoxes and, as the source claims, lacks clear experimental proof, should we just trust the consensus of the last 300 years?
Yeah, no, you have no evidence, and just because you all fell for it and you all believe it, everybody should continue to believe it because that's good science. Believing without evidence, that's the definition of science. No, that's the definition of religion. So that's all this is become. Physics is just a religion. Sadly, deplorably, disgustingly. I say with a grave disappointment, as somebody who loved science. Sadly, that's all they want out of it. They're probably child molesters too. Religion. That's all they want.
Or is it maybe time to take another look?
Yes, it's time. Way past time. Alright, so that's one video that isn't. So I am going to upload these things to YouTube as unlisted videos. So I have some of them there already. And, I'll put up some others. And so some of the other artwork also I'll make available that I have put into the other videos. But again, the one I did before, where I took an audio file and I put the images in, frankly, it's just it's a much better AI video. But whatever. So you got a couple of comments by Forced Reality. I understand your model. It almost doesn't make sense how you can disagree with a model like yours. Yes, it doesn't make sense that... like I said, these are not challenge. Speed of force, this is not a challenging concept. Push, not a challenging concept. And again, when you show a simulation, actually showing charges, and showing how a charge is made, how electrons and protons can be completely described in terms of their basic function, all right, with just such a simple model. To not take that seriously is just... again, you have to have no scientific integrity. You have to have no interest in real science to ignore a model that simple. Alright, since seeing your channel, I haven't seen reasonable counter-arguments that challenge your model rationally. That's right. Well, I guess we're never going to. Unfortunately, because people are just religious kooks. And they just want to argue their faith. They don't want to argue facts, and you can see that it's almost every subject is perverted by people's biases, and that's all there is. Whatever mommy told them, they can't think past those friendly fables. I have noticed, it was just kind of funny that it came up in my recommended videos. And, there was this It was a pretty bad cartoon, but the Bullwinkle and Rocky show, and then they would have Aesop's fables, and then they would do perversions of some other fable. What were they called? Well, anyway. And they were so cynical, so they took like the rabbit and hare story or Goldilocks or some other silly little and they twisted it and perverted it. And it was, they're all kind of funny and all kinds of very almost Monty Python-esque in terms of mocking humans. I mean, they were, they painted humans were really stupid, basically. I mean, the whole show basically showed that. I mean, the whole Bullwinkle jokes were just so stupid. I mean, the whole thing was just so stupid. I mean, really, there was a half hour of mocking humanity. And it wasn't my favorite cartoon, I have to say, but I mean, I did love the little fable bits, and the Aesop thing was great. But and the dog, Mr. Peabody, that was pretty good. And yeah, I almost wanted to call. I had a dog. It turned out to be a black and white beagle. I almost wanted to call him Mr. Peabody. Ended up calling him Petey instead. But So anyway, my point is, I guess all cartoons did that, right? I mean, even the Bugs Bunny and all the rest of them were all kind of making a joke out of human beings, Elmer Fudd and all that stuff. And so I don't know how you could grow up on anything like that, and just, it's pretty, and get some sense of, humans are ridiculous. People are so stupid and foolish. Gee, this isn't that complicated, is it? Is it really that hard not to be evil? Oh, no, I know, it's not that hard not to be evil. Well, it's just funny. All right, obviously MV has worked on the lever fine for thousands of years. Yes, well, obviously for thousands of years, people believe they conserve momentum, that's for sure. Now they're claiming, they have the new claim that, no, it doesn't. But they're certainly never going to prove that silly new claim. So that's the part. We'll never see evidence of its failure to work and such. All right, so let's see. Do I have the will or the energy to do more tonight? I guess probably not. Big snow coming Ew, this weekend. And I have a bunch of driveways I have to shovel. Some of them just out of the kindness of my heart, for old people. Ugh. That's where I guess being a nice person sometimes is a pain in the ass, because you actually get yourself into something. You say, "Oh fuck, why did I get myself into that?" But whatever. Well, we'll see how bad it is. They always make it out to be all hysterical, like the end of the world's coming with every storm, and frankly, if it's less than a foot, well, you just, whatever, you deal with it. So anyway, I've been getting snow blowers out of the garbage over the years, so I have like 5 snow blowers, but none of them work. Actually, everything works on any one of them. So it's like I have a nice heavy duty one, but it has a busted tire. And I'm too cheap to buy a new tire. And then I got, it's like I got a smaller one, but the carburetor's float. It's got a hole in it, so it leaks too much gas. I got another one that's some other bullshit issue, and it's just kind of funny. Then I got the one that does work, but the pull cord doesn't catch. So you have to try. You have to sit there and move it really slowly until you finally get it to catch, and then you can pull it. So it's like you have to do a little work to get it started, but once it's running, it works really well. But anyway, just kind of funny. Half the time, snowblower, I mean, especially here, everything is, there's too many cars, there's houses are so close together, it's almost, you know, it's easier just to shovel, but we'll see. And such. That's more than you need to know. Let's see, what else is news? I think that's it for news. So, like I said, I did put some of these crappy AI videos on the website. So do the draft physics, no, the debate physics website. There's a couple of them. And I'll put the PDFs up that have all the images in them. Some of the images are quite good, you know, and some of them are quite ridiculous. But anyway, I'll get around all of that and such. Alright, so I guess I'll get the hell out of here. I guess as usual we just don't have enough conversational interaction to justify my continued participation. Yeah, 7 viewers. Not quite enough. Alright, anyway, so till the next time and such and so forth and whatnot.